Alright, this one for Metamorphic Rock's a little shorter than the other one, so it shouldn't take you long to do this last one. Your objectives today are describe the process of metamorphism, explain the difference between regional and contact metamorphism, and finally distinguish between foliated and non-foliated metamorphic rocks and give an example of each type. That's it on the objectives. Pretty simple one. Metamorphism is the process in which one type of rock changes into a metamorphic rock because of chemical processes or changes in temperature and pressure. So you're going to see, because of the chemical changes in the rock, you're going to get a different rock than when you started. Heat and pressure, hot fluids cause that mineral, some of those minerals to change into other types of minerals. They may also change shape or size, and sometimes they'll darken in color and lighten in color, and you'll get bands that look like bands in the rock itself. And hot fluid may circulate through the rock and change the mineral composition of the rock by adding some minerals and taking some minerals away. The type of rock that forms under metamorphism can indicate the conditions under which the rock changed. So what that means is that according to what it comes out, you have a type of rock, we can look at that rock and say, okay, this must have happened when this was going on. Composition of rock being metamorphosized, the amount of direction of pressure, the presence of certain fluids, we can all look at those and decide, okay, that made these minerals form, meaning that this happened to this rock. It's a way for us to find a history of the rock to know what happened to it. There's two types. There's the Earth's crust contact metamorphism and regional metamorphism. So contact and regional. And here's a picture of them, the mitten-looking thing that's there, the magma. The area that's in gray is the brown layer of that area. That's called, that would be under the regional metamorphism. So the whole area around that brown area around it is being changed because of the heat given off by the magma and the pressure it's under. The gray area is called contact metamorphism. That gray band around the magma, that's where it's touching the magma. It actually has to be touching to have contact. So there's contact, change in texture, structure, or chemical composition of rock due to contact with magma. Regional, a change in the texture, structure, or chemical composition of rock due to changes in the area. So you have a large general area. The heat, as the heat comes out of the magma, it changes rocks over a much larger area. Usually tectonic forces, which we'll spend a lot of time talking about in the coming weeks. Here's your reading check. How are minerals affected by regional metamorphism? Pause the video right now. And you're back. Okay, here's your answer. High pressure and temperature result from the movement of tectonic plates may cause chemical changes in the material minerals. Foliated rocks. That's metamorphic rock textures in which a mineral grains are arranged in planes or bands. So foliated rock will actually have layers, like we talked with stratification of the soil. That's what it looks like in the rock. We may get mineral crystals in the rock to reline or regrow, and those crystals will form those parallel bands that we see. You can also get foliation as minerals that have different compositions separate. So some are more dense than others, so they'll separate out, and you'll get bands of lighter, darker, lighter, darker. And here's some examples: slate, schist, and gneiss. Non-foliated rocks, they don't have planes or bands. They may contain grains of only one mineral, or they can have small amounts of other minerals. So you don't see those bands forming like you do in the other one, the foliated rocks. They have grains that are square around, so they mix. These grains are unlikely to change shape or position when exposed to direct pressure. So as the pressure builds up on them, you're not going to see a lot of changes in this type of rock. And you'll see a lot of marble and quartzite in these. Marble's one of the common building blocks around our country, especially in Washington, D.C. Some of our most famous monuments are built of marble. Here's a map, and this map shows the different layers of things that happened in the country. And each one of those layers with the different colors is a different time period in history. And we find different things about the rocks of that area by looking at this map. And you can take some time to look through it. It's kind of interesting. We're not going to ask any questions about this, but it is kind of an interesting map. Alright. Well, thank you for watching this slide. That one wasn't too bad, I don't think.